Okay, now notice in number 2, I just filled in some numbers early on here. It says the voltage is 18. Okay, remember voltage is joules per coulomb. It's how much energy there is in each coulomb. Now, this one is 25 and this one's 40. So if we use this equation, I equals V over R, on these sheets it's been written using a C for current. So C equals V over R. If you follow this path, the voltage is still 18, the resistance is 25. And when you divide those two, you get the 0.72. Now, it's going to be 0.72 all along here. So at A, B, and C, it's 0.72. Now, if the coulombs take the other path, okay, if they take the other path, then the voltage is still 18, but now the resistance is 40. And if you take 18 divided by 40, you'll get 0.45 here. So this is 0.45 and 0.45. And in the problem that we just did, remember that right here and right here is the sum of these two currents through this path and this path. So if you have 0.45 coulombs per second here, and you have 0.72 coulombs per second here, then these two together right here at G and also at F, before they divide up, and here's after they have divided up and they're back together again, that's why at F and G you will have a total of 0.45 and 0.72. Okay? Now, the last thing that comes up in this chart is the joules carried by each coulomb. So on this side of the battery, they each have 18. And so at F, they have 18. Okay, at F, they have 18. Then at B, they haven't gone through the bulb yet, so they have 18. Here, they've gone through the bulb, so they have 0. At C, they still have 0. And then over here at D, before they go through here, they have 18. And then at E, they've gone through the bulb, so they have 0. And then at G, they also have 0. Okay. In number 3, every 4 seconds, 10 coulombs pass through bulb 1. Now, we're given that the resistance here is 8 ohms, so I just wrote it right above that bulb. I think that's an easier, a good idea, is just fill in the diagram. Now, the current is 10 coulombs every 4 seconds. 10 for every 4 seconds, okay? So now, that would be the same as 2.5. Now, if you use it as 2.5, it's fine, okay? Or if you want to use 10/4. But again, now we're going in the other direction, is we don't know what the voltage is here, okay? We don't know what the voltage, but we know the current and we know the resistance. So this is 2.5 coulombs per second that's going through that bulb. The voltage is the current times the resistance. So when you multiply those two, you're going to get 20 joules per coulomb. And again, since it's parallel, if it goes through this part or this part of the circuit, both voltage drops will be the same. So now we know that this voltage it must be a 20 volt battery. Okay, and now in part B, how many joules? Well, that's still going to be 20 because it's a series, it's a parallel circuit. So it's parallel, which means that whether the coulombs go this way or whether they go this way, they we'll lose 20 joules per coulomb. Now, once we used the resistance and the current here to figure out the voltage, now what we can do is go back and figure out what the resistance is of bulb number 2. And here we know that 6 coulombs pass through bulb 2 in every 4 seconds. So that means that the current through the second part would be 6 coulombs every 4 seconds, which is 1.5. Okay? Now, if we know the voltage is 20, which we calculated using this current and this resistance, then we know that 20 divided by 1.5 gives us 13.33. So this must be 13.33 ohms. Okay, so again, we were given this resistance, we're given this current, we can get the voltage. Once we get the voltage, we use that same voltage along with the current to figure out the resistance right here. Okay? Now, it says how many coulombs through A, B, and C every second. Okay? Every second. So now we know that the current through here is 2.5. We know the current through C is 1.5. So that means that right here it would be 4. Through C it is, through C it's 2.5, right? We did that earlier. That was given to us actually, 10 divided by 4. And here through this one is 1.5. So once again, the current through here, the current through here is equal to the total current here. Now, your teacher didn't ask this, but the current through this point right over here would also be 4. Okay? Now, in F, it says how many joules are being released every, bulbs 1 and 2 every second. Joules per second. Joules per second is a unit of power. And when we're using, when we're trying to figure out power, we're going to use this equation of power equals current times voltage. Current times voltage. We have this current, same voltage, but different currents. Okay? Okay. In number 4, light bulb 1 has a resistance of 10 ohms, so I put it right here. 2 has a resistance of 20 ohms, so I put it here. And they give us the voltage. They give us the voltage here. So now, if the coulombs go through this bulb, okay, if they go through this bulb, then the current will be 9 divided by 10, which is 0.9. You can see here that the current is 0.9. Regardless of which path they choose, same voltage, 9 volts. And then the joules released every second, that's power. So power equals voltage times current. Voltage times current. Voltage times current. So we have 9 times 0.9, 8.1 joules per second. Now, a joules per second is a unit of power, and it's called a watt. In number 2, we have to figure out the current first. So we're going to take 9 divided by 20, and that will give us 0.45. Now, if this has a current of 0.9, all right, through bulb 1 is 0.9, and through bulb 2 is 0.45, then the current through the battery is going to be a total of that. So that gives you 1.35. Okay. Now, number 5 is a little bit strange in that none of the voltages or the resistances are given to us. So just to make it easier, I picked some resistances and voltages. They're all the same, but I think it just helps figure out what's really going on here. Okay. Now, this is what we call a series circuit. Okay, this is a series. So the voltage is 30, but some of it will be used here, some will be used here, and some will be here. The current will be the same throughout this whole circuit. Over here, some will go through here, some will go through here, and some will go through here. Now, the voltage drop is still 30 volts, but notice what happens to the current here. This would be 30 divided by 10. 30 divided by 10, and that would be 3 amps. So 30 divided by 10 gives us 3. So we're going to have 3 amps, 3 coulombs per second through this bulb. We're also going to have 3 through here. We're also going to have 3 through here. So because it's set up in parallel, you're going to have 30 divided by 10, 30 divided by 10, 30 divided by 10. So 3 amps, 3 amps, 3 amps. Right through G, you're going to end up having a current of 9 amps, 9 coulombs per second. Over here, you have a resistance of 30. And if you take 30 divided by 30, you get 1 amp. Okay? So which points have the greatest current flowing through it? Okay? It's going to be G. G is going to have the greatest current. Okay? Now, which light bulbs take the greatest number of joules from every coulomb? Here, the 30 volts is going to be divided up between this one, and this one. Now, because they're all the same, this one will lose 10, this will lose 10, and this one will lose 10 for a total of 30. But in this circuit, this is a parallel circuit, each branch that contains a bulb, there will be a drop of 10. So this will be 10. Each will have a drop of 30 because the resistances are the same. So if you go this way, there's a drop of 30. If you go this way, there's a drop of 30. If you go this way, there's a drop of 30. So which light bulbs take the greatest number of joules from every coulomb? That would be bulb 4, bulb 5, and bulb 6. Bulb 4, bulb 5, and bulb 6. They will take the greatest number because each one will be 30 joules per coulomb. Voltage is joules per coulomb. So regardless of the path, they're each going to get the full voltage drop. Here the voltage drop is divided among the 3.